ASML of the Netherlands has always been a core technology supplier to the semiconductor industry. Due to the high precision and complexity of lithography machines, Chinese scientists realized that they were unable to independently build lithography machines with their own technical level. Therefore, they adopted the strategy of building photolithography factories to bypass technical limitations and accelerate the development and production of semiconductor chips. Welcome to subscribe to Silicon Dragon. We are a YouTube channel focusing on chip technology. We will bring you the latest technology information on the technology war between China and the United States. The photolithography machine is the core equipment in the semiconductor chip manufacturing process. It uses optical principles to project light onto the photoresist to form chip patterns. The manufacturing and operating processes of photolithography machines are very complex and require extremely high material purity, light quality and stability. Only a few companies can master its manufacturing technology and patents, and it is not realistic to independently build photolithography machines. Dutch ASML's lithography machines adopt a miniaturized design to facilitate export and transportation, but China does not need to export and is not subject to transportation restrictions. Chinese scientists have decided to build a large-scale photolithography factory. They can select appropriate light sources according to needs, manufacture chips at different nanometer levels, and produce multiple models at the same time. The advantage of this strategy is to bypass technical limitations and speed up the development and production of semiconductor chips. In contrast, ASML's lithography machine in the Netherlands can only manufacture one type of chip at a time, and its production capacity and flexibility have certain limitations. Chinese scientists plan to build the photolithography factory into an assembly line-style production line to produce chips of various specifications. This will help meet China's huge chip market demand and reduce the price of chips. Once the lithography plant is built and put into mass production, chip prices are expected to drop significantly, which may have a significant impact on the global semiconductor industry. The move will also speed up China's road and innovation in the semiconductor field. By building photolithography plants, Chinese scientists will be able to better master the core technology of semiconductor chip manufacturing and promote the development of China's semiconductor industry. This will help enhance China's status and influence on the international stage, and provide more support for China's scientific and technological innovation. Although Chinese scientists have decided not to pursue the goal of independently building lithography machines, this does not mean that they are no longer important to the research and development of lithography technology. Instead, they will focus on building a photolithography factory and turning it into a semiconductor chip manufacturing base with independent research and development capabilities and production capabilities. The construction of photolithography factories will also drive the development of related industries. As the core equipment for semiconductor chip manufacturing, the construction and use of photolithography machines requires a large amount of material supply and technical support. The construction of the lithography factory will drive the production of lithography machine-related parts and materials, and will also provide more development opportunities for related companies. There are also some challenges and risks associated with directly building a lithography fab. First of all, the construction of a lithography plant requires huge investment and resource support. Building a lithography plant with high precision and stability requires a lot of financial and technical support. At the same time, the operation and maintenance of the lithography plant also requires professional and technical team support. The construction of lithography factories needs to fully consider environmental and safety factors. The operation of a lithography plant involves a series of chemical substances and high-energy equipment, which places higher requirements on the environment and worker safety. A series of effective measures must be taken to ensure the operational safety and environmental protection of the lithography plant. Good news comes from the Netherlands. The ban on photolithography machines will not be implemented for the time being. China can seize the last moment to purchase. Recently, news that the Dutch government will not implement the ban on lithography machines has reached China. This news has attracted widespread attention. Many Chinese companies have seen business opportunities and hastened to purchase lithography machines. The Netherlands has been developing and producing lithography machines since the early 1990s and has since become one of the world's leading lithography machine manufacturing countries. However, because photolithography machine technology plays an important role in national security, in 2019, the Dutch government issued a series of restrictions on the export of lithography machines and plans to completely ban the export of lithography machines in 2022. The Dutch government's temporary non-implementation of the ban has created a rare opportunity for China to purchase lithography machines, which means that Chinese companies have more time to purchase advanced lithography equipment to accelerate the development of the domestic chip industry. At the same time, this also provides an opportunity for Chinese lithography machine manufacturers to develop and expand the market. Although the temporary suspension of the ban in the Netherlands is a rare opportunity for Chinese companies, it also faces many challenges. First of all, the Dutch government may change its policy at any time and impose restrictions on the export of Chinese lithography machines. Therefore, companies need to make careful decisions to prevent sudden policy changes after purchasing. Secondly, Chinese companies need advanced technology and product quality to stand out in the fierce global market. Finally, companies also need to solve funding problems. Purchasing lithography machines requires huge financial support, and companies need to find reliable financing channels to ensure the sustainability of funds. The good news from the Netherlands brings both opportunities and challenges, and will have an important impact on the development of China's lithography machine technology. First of all, by purchasing advanced lithography equipment, Chinese companies are expected to achieve technological breakthroughs and improve the core competitiveness of the domestic lithography industry. Secondly, the Netherlands' temporary non-implementation of the ban will also encourage Chinese lithography machine manufacturers to increase investment in technology research and development and innovation to improve product quality and market competitiveness. However, this also means that Chinese lithography machine companies will face more intense market competition and need to continuously improve their own strength to cope with challenges. In the context of the temporary suspension of the Dutch lithography machine ban, Chinese companies should seize the opportunity to purchase lithography machine equipment while increasing investment in research and development to enhance their own strength. The government should strengthen supporting policies and provide more financial and policy guarantees for the lithography machine industry. Looking to the future, China's lithography machine technology is expected to gain a larger share of the global market, thereby promoting the rapid development of China's chip industry. The good news from the Netherlands is of great significance to the development of China's lithography machine technology. Although facing some challenges, by seizing opportunities, Chinese companies are expected to accelerate the development of the domestic chip industry. With the joint efforts of the government, enterprises and the market, it is believed that China's lithography machine technology will achieve greater breakthroughs and inject new impetus into China's scientific and technological development. Recently, a piece of news about Micron was exposed in China, which attracted widespread attention from the international community. Relevant Chinese authorities inspected Micron's products and found that most of them were deemed substandard. This discovery triggered a series of chain reactions, leading to further escalation of trade tensions between China and the United States, the Netherlands and other countries. First, let us review the whole story of this incident. The Chinese government departments conducted a detailed inspection of Micron's products, and finally determined that most of the products did not meet China's quality standards. This has aroused concern from the Chinese government, because these products involve semiconductor technologies of concern and are of great significance to China's technology industry and national security. Therefore, China took quick action to ban the sale and use of Micron's products in China, which was considered a legitimate act to safeguard national interests. However, the U.S. government interpreted this maliciously, claiming that China had slandered Micron without providing sufficient evidence, and threatened to unite with its allies to impose sanctions on China. Such comments have sparked concern among the international community, as they could lead to further instability in the global trading system. At the same time, Japan and the Netherlands have also issued export restrictions related to China. It is particularly noteworthy that Dutch Foreign Minister Hoekstra said during his visit to China that the Netherlands plans to announce details of the restriction order on chip exports in the summer. This move further aggravated the international community's concerns about China's trade situation. During the talks between Hoekstra and Chinese Foreign Minister Qin Gang, both parties expressed their willingness to strengthen cooperative relations between the two countries. However, at the press conference after the meeting, Hoekstra made some controversial remarks, sparking speculation. He mentioned that the Dutch government will announce the details of the restriction in the summer, which has been interpreted by the outside world as the Netherlands may impose restrictions on certain investments in China. This statement disappointed China, which has always hoped to maintain friendly and cooperative relations with European countries such as the Netherlands. The United States and its allies frequently impose bans on Chinese chips, causing huge damage to Chinese companies and the global economy. Such behavior is not only irresponsible, but also violates international rules and morality. In today's highly connected world, electronic products and information technology have become an indispensable part. The U.S. government's actions have forced China's chip manufacturing companies to suspend production and exports, causing significant losses to China and the global economy. In addition, this behavior also disrupts the stability of the global semiconductor industry chain. Although the United States and its allies try to defend the ban on Chinese chips, saying it is to safeguard national security and technological leadership, such unilateralism not only harms China's interests, but may also have a negative impact on global technological innovation. The international community should resolutely oppose such irresponsible behavior and safeguard the principles of free trade and fair competition. When faced with the challenge of the ban on Chinese chips, it is necessary for China to strengthen the independent innovation capabilities of its domestic chip industry. Only through independent research and development and innovation can China occupy a more competitive position in the global semiconductor market and better protect its national security and economic interests. At the same time, China should also actively seek international scientific and technological cooperation to jointly promote the prosperity of global scientific and technological development. In short, the ban on Chinese chips is an irresponsible act that has caused serious damage to China and the global economy. The international community should unite to oppose this act and safeguard the principles of free trade and scientific and technological cooperation. China should also strengthen its own strength to better cope with current and future challenges. Only in this way can we jointly promote the stability and prosperity of the global economy and technological development. Not long ago, a famous Big V made a shocking statement to the effect that the next generation lithography machine is not EUV, but must be an X-ray lithography machine that is more advanced than EUV lithography machine. This kind of lithography machine is amazing. The wavelength it uses is less than 10 nanometers, or even 0.01 nanometers, which can achieve more precise writing in smaller processes, such as manufacturing chips below 1 nanometer, without any problems. In this field, our scientists have done a lot of research and accumulated a lot. The next generation of lithography machines will definitely make breakthroughs in this field. Therefore, this Big V believes that China must make the next generation X-ray lithography machine first. Even the Netherlands cannot do it because the market is gone, and China will be the major chip manufacturing country in the future. So is the X-ray lithography machine really that awesome? EUV lithography machine is the crown jewel of the chip industry. The EUV lithography machine of Dutch ASML can be said to be extremely precious. With it, you can produce 7 nanometers and 5 nanometers processes. It is reported that an EUV lithography machine with an advanced process costs US $120 million, weighs 180 tons, has more than 100,000 parts, and requires more than 2 kilometers of hoses to be transported in 40 containers. It only requires installation and debugging. It takes about a year. Parts and components come from more than 5,000 supplier companies around the world, such as Germany, Japan, Sweden, the United States, etc., and they are all at the top technical level in the industry. Chinese chips are stuck in the United States because they do not have EUV lithography machines. Although Huawei has released the Mate 60 Pro 5G mobile phone, the chip manufacturing process is 7 nanometers. Rumors say that it is the credit of SMIC, which used the current DUV lithography machine to achieve it through multiple exposures. This is already the most advanced level in China, and it is also the maximum capability that DUV lithography machines can exert. If we want to break through further, we can only use EUV lithography machines, due to well-known reasons. Although SMIC spent money to purchase from ASML, the latter has not yet shipped the goods. Lithography machine, simply put, is a machine that uses light as a blade to carve chip drawings on the wafer. It is the most basic and critical part of chip production and processing. The lithography machine can be compared to an advanced projector. Its function is to project the pre-designed chip circuit pattern onto the silicon wafer. Of course, it does not use general light, but a specific light source. So far, EUV lithography machines can be said to be the most advanced lithography machines. Why can TSMC monopolize more than half of the world's chip foundry market? Especially in the 5 nanometers and 3 nanometers processes, it is even more lonely and seeking failure. The big reason behind this is that it has nearly 50 EUV lithography machines. So why is EUV lithography machine so powerful? Imagine you are drawing lines on paper with a pencil, and EUV technology is equivalent to a pencil with a very fine tip. EUV's light has a shorter wavelength than the light used by traditional lithography machines, which means it can draw thinner and more precise lines. This is very important for chip manufacturing, because thinner lines mean that more components can be put on the same size chip, thereby improving the performance of the chip. In short, with EUV lithography machines, high-end chips with 5 nanometers or smaller processes can be produced. In this regard, the famous Big V believes that the development route from DUV to EUV is the technology of Americans and Europeans. In fact, we do not need to follow the Western route, but must make breakthroughs. Of course, this does not mean that we will not make EUV lithography machines. We must do it. However, if we want to be competitive with foreign countries, research on X-ray lithography machines is also essential. X-ray lithography machine. Many people may be confused when they hear this. What is this thing? Why haven't you heard of it? X-ray lithography machine is actually an X-ray lithography machine. The wavelength it uses is much smaller than DUV and EUV. The wavelength can be less than 10 nanometers, or even close to 0.01 nanometers. Such a short wavelength can theoretically achieve smaller feature sizes, thereby creating higher integrated chips. For example, chips below 1 nanometer can be manufactured, but why don't we hear it more often? The reason lies in the complexity and challenge of this technology. For ultraviolet light such as DUV and EUV, we can use glass or other materials to make lenses or reflectors. Especially in EUV lithography technology, the use of multi-layer film mirrors is the key to achieving pattern projection, but for X-ray lithography machines, this method cannot be used, because X-rays are so penetrating. Traditional reflection and refraction techniques simply don't work here, so a very special mask, or reticle, is needed. This mask must be able to absorb X-rays without being damaged by them. Designing and manufacturing such masks is very complex and expensive. Secondly, the equipment that generates and accurately controls X-rays is relatively complex and requires special protective measures to ensure safety. Because X-rays are a type of ionizing radiation, they already belong to the category of nuclear radiation, and can cause a certain degree of damage to the human body, it is also difficult to make X-rays pass through specific materials, constantly change directions, and finally focus on a point. In fact, scientists began to develop this technology more than 50 years ago. At the time, as semiconductor technology continued to advance, requiring ever higher resolutions, X-rays attracted attention because of their very short wavelength, as it theoretically had the potential to provide a method for fabricating chips with smaller features. However, due to the above-mentioned technical and economic challenges, X-ray lithography machines have not yet been widely adopted in commercial-scale chip production. Other technologies, such as DUV and EUV lithography, dominate. These technologies are relatively more mature, reliable, and more compatible with existing manufacturing processes. Even so, famous influencers are still very optimistic about this technology. He believes that in this field, our scientists have done a lot of research and there are a lot of with more accumulation. The next generation of lithography machines will definitely break through in this field. He also made a very exciting statement. He also believed that the next generation of X-ray lithography machines must be made by China first, and China will also be the major chip manufacturing country in the future. I checked the information, and what he said about many domestic teams researching and developing X-ray light source lithography technology is indeed true. Shanghai Institute of Optics and Mechanics. The institute has been researching X-ray lithography machines since 2006, with the goal of developing a soft X-ray lithography machine with independent intellectual property rights to achieve high precision and high-resolution lithography. The Institute of Optoelectronics Technology, Chinese Academy of Sciences, has conducted in-depth research on X-ray micromachining technology and developed a nano-level ultra-precision cutting technology based on X-ray microscopy. It utilizes the characteristics of X-rays and the interference effect of optical elements to achieve ultra-precision cutting and high-precision processing of nanoscale steps. University of Science and Technology Beijing, in cooperation with Shanghai Institute of Optics and Mechanics, jointly carried out research work on X-ray lithography machines, mainly studying X-ray optical systems, X-ray sources, beam shaping and beam quality assessment. Nanjing University. The high-precision optics team of the School of Physics of the university studied the impact of surface roughness of optical elements on the imaging quality of the optical system, proposed corresponding solutions, and applied them to soft X-ray microscopes. These teams have made certain progress and achievements in the technological research and development of X-ray light source lithography machines, and have promoted the development of domestic X-ray lithography machine technology. To sum up, the battle for lithography machines between ASML and China continues, and future development is full of variables. In any case, this competition will promote the continuous progress of the semiconductor industry, and will also affect the evolution of the global technology landscape. In this rapidly developing technological era, lithography machines are regarded as the core element of China's high-tech progress. They are not only the core of chip manufacturing, but also represent the country's comprehensive strength in the microelectronics industry. For a long time, China has been restricted by technology blockade strategies in key technologies such as photolithography machines, especially policy pressure from the United States and its allies. The Dutch company ASML once maintained a conservative technology export policy towards China, but has recently changed its policy and allowed it to continue exporting lithography equipment to China, which has attracted widespread attention. Not only that, in the field of biotechnology, Chinese researchers have also made remarkable achievements, especially in the fields of rare disease treatment, gene editing, and nuclear regenerative medicine research. These achievements have not only attracted widespread attention domestically, but have also been recognized by international peers. However, in the face of external technological blockades and sanctions, we must remain vigilant and strengthen our independent innovation capabilities. This includes finding and cultivating reliable partners, developing alternative technologies, improving the self-sufficiency of domestic industries, and cultivating high-end technical talents. At this critical moment, we cannot just rely on the external market and technology supply, but should redouble our efforts to maintain technological independence and autonomy to ensure China's continued leadership and development on the global technology stage. Only in this way can we remain invincible in the wave of science and technology and jointly promote the scientific and technological progress and civilization development of mankind. 3 years ago, Huawei fell into a continuing storm of suppression. The United States gradually forced the Chinese technology giant into a corner by restricting the export of chips, technical equipment and components for technology companies. Chips are the lifeline. Without them, Huawei's plight is obvious. However, this suppression is not just the fate of Huawei, a Chinese company. The United States has ambitions beyond Huawei. It hopes to consolidate its dominant position in the global chip market by comprehensively suppressing China's technology industry under the new chip regulations. Chinese companies are unable to purchase EUV lithography machines from ASML and can only seek DUV lithography machines with outdated equipment. However, 3 years of suppression have not met U.S. expectations. Recent news broke that the United States plans to form a new blockade alliance with Japanese and Dutch companies, which has further blocked China's technology industry. This news shows that the United States is in a state of high tension and has not given Chinese companies a chance to breathe. Lao America is well aware of the difficulty of developing photolithography machines, so they seized this opportunity and suppressed Chinese companies mercilessly, not even letting go of the last glimmer of hope. However, the laws of physics tell us that forces work reciprocally, and the United States' suppression of Chinese companies will inevitably trigger counteractions, forced to hit U.S. companies or allies. Bill Gates has made it clear that sanctions against Chinese companies are detrimental to the development of American companies. But the United States has gone its own way, causing opposition and disregard from its allies and the international community. Recently, good news came from Chinese companies. They successfully purchased ASML's photolithography machines. These lithography machines were independently developed by Shanghai Microelectronics. Tungsingda Technology Company purchased 2 of them. The first lithography machine has been delivered with a transaction price of 18 million yuan. This successful progress means that domestic lithography machines have made a huge breakthrough and are more competitively priced. Once domestic lithography machines can achieve mass production, will lithography machine manufacturers such as ASML, Canon, and Nikon continue to attract Chinese companies? Obviously, the United States' suppression measures have harmed its own interests. Its allies are likely to become the biggest victims, and American chip companies will also suffer huge losses. As Bill Gates said, U.S. sanctions will only accelerate the development of Chinese companies. The ultimate goal of self-developed lithography machines is to achieve self-sufficiency in chips and reduce dependence on U.S. chip companies. According to data, Chinese companies will reduce imported chips by nearly 96 billion in 2022, an average of 8 billion per month. This means that chip imports have decreased, and the proportion of domestically produced chips has increased. China has shown its tenacity in this game. As the world's largest importer of chips, U.S. companies will face a huge risk of sales decline if Chinese companies no longer rely on external chips. U.S. companies such as Intel and Qualcomm have already felt this meaning, and have emphasized the importance of the Chinese market. But no matter what the attitude of American companies is, China has already recognized the situation and no longer has any illusions. From this perspective, the suppression by the United States also has positive significance for China. To sum up, Huawei's predicament is just a crackdown on China's technology industry. But Chinese companies are overcoming difficulties through independent research and development and gradually achieving self-sufficiency in chips. U.S. sanctions have accelerated the development of China's technology industry, and may have harmed its own interests. This trend has a profound impact on the global technology landscape, and makes people think about the future direction. Thank you very much for watching, and we hope the information we have provided will be helpful to you. If you have cutting-edge information you would like to know, please leave us a message.